See this problem. A condenser of certain capacity is charged to a potential V and stores some energy. A second condenser of twice the capacity is store half the energy of the first. Find to what potential one must be charged. Our motto is, we have been given two capacitors like this. So each capacitor has its capacitance C1 and C2, and it has energy E1 and E2. They are charged at potentials V1 and V2. So for some conditions we need to find out V2 at what potential the second one will be at double the capacitance of the first one and having half of the energy of the first one. Those two are the conditions, and we need to find out the second potential. Now I'll move to the investigation. What type of quantities that are given? First one, capacitance of the first one is equal to C. Capacitance of the second one is equal to double than the first one, that is 2C. And energy of the first one, E1, is equal to, let it be E, and second one is equal to half of the first one, that is E by 2. And first potential V1 is equal to V. Second potential is the unknown thing, so that is the thing we need to find out. And now I am resolving the problem. So we already know that the energy of a capacitor, assume that it is for first one, E1 is equal to half C1 V1 square. E2 is equal to half C2 V2 square. Those two are the expressions for the energy of a capacitor. Now I am taking ratio between these two energies, that is E1 by, or take it E2 by E1. E2 by E1 is equal to half C2 V2 square divided by half C1 V1 square. So half gets cancelled. Now I am writing the given quantity. E2 is equal to E by 2 by E1 is equal to E is equal to C2 2C by C1 C into V2 square by V square. So C gets cancelled, E gets cancelled, so the remaining things are half is equal to 2 V2 square by V square. I need V2, so V2 square, I am keeping this V2 square here and moving this V2 that side, so I'll get V square by 4. That implies V2 is equal to V by 2. So at half of the potential you will be having half of the energy than the first one at the capacitance, at the double the capacitance of the first one.